Now, hi everybody. You're very welcome to the March part of the Earth Observation webinar series, and we're presenting remotely today. There's people still coming in, so we'll just give it maybe a minute or two. Nice to see the turnout today, that's great. We have two speakers today. We have Indiana Albert from the University of Galway, and we have Sinead McGlynn from TechWorks Marine. And they're both going to talk a bit about water today. That's kind of our theme, a bit about water quality and water monitoring. So just to say, this webinar series is supported by the EUROGI Women in Geospatial Irish Chapter. If you're interested, check out our LinkedIn page. Maybe Marion can post the link to that in the chat so people can have a look for themselves. And also, if you are a woman doing geospatial work, please let us know if you'd like to present at one of these webinars. This series will go on till the end of the year, and we have a few slots open, mostly after September. But if you'd like to get your work out there and showcase yourself and your work, then please get in touch and we will fit you in. So I think we'll start. Sinead, will you come first? So in this series, the speakers will present themselves, which is handy for me. So I'm just going to hand over to Sinead to do that. Thanks very much, Sinead.
Sure, thanks very much. Let me just reshare my screen and hopefully it'll start up. Okay. So can you see that okay?
Yeah. Yeah,
okay, great.
Good.
Perfect. Okay, so hi everybody. It's really great to be able to speak here this afternoon. My name is Sinead. I am the COO, the Chief Operations Officer at TechWorks Marine, and I'm going to give you a little bit of an overview of my kind of career path, I suppose, to date, and then talk a little bit about the company and how we use Earth observation for marine monitoring. So, just going to, there we go. So, my career path is not anything to do with geography or Earth observation, really. What I started off doing was physics. So I'm a physicist background. I did my undergrad in Trinity, starting off with science. Back in those days, you had to pick 3 subjects to start off with. So I started off with maths, physics, and chemistry. In the 3rd year, I think I had to pick what I wanted to do to specialize in, and I picked physics, but I picked physics with astrophysics because I thought that sounded pretty cool. You know, when else are you going to have a chance to study some astrophysics? You get to skip some of the more horrible, complicated physics and learn about galaxies, neutron stars, all sorts of things. So I thought that sounds interesting, you know, let's see what happens. I wasn't really thinking in too much detail about what I would do next. And when I finished my degree, then I ended up doing a PhD in astrophysics in UCD. So I moved from Trinity to UCD, which, you know, for some people is, you know, a major sin. For other people, it's a major benefit, saying, oh, I've gone from one dark side to the other side. So in 2008, I finished my PhD. So I was studying these phenomena called gamma ray bursts. So it was very much, you know, much more abstract than any kind of Earth observation. I was using telescopes. So I was using telescopes that were obviously pointing out away from the Earth and not towards the Earth. So you can see there's a telescope here in the corner, which is called the Fermi Gamma Ray Space Telescope. And that's a joint mission between NASA and the European Space Agency. And it's actually, the big grey box on the top of it is actually the detector. So it's not pointing towards Earth at all. It's pointing far away. It's pointing right into the rest of the observable universe. So I was studying gamma ray astronomy. So basically the very highest energy rays that are emitted from anything. And gamma ray bursts are basically what happens when a neutron star collapses into a black hole. So your neutron star is kind of reaching the end of its life, it collapses into a black hole and it's spinning very, very rapidly. So it sends 2 jets of electromagnetic radiation out. And the gamma ray burst is the first thing that comes out because it travels the fastest, because it has the highest energy. So you can pick up these things from really, really, really way back in the universe's lifetime. But you will only see a very small bit because there's basically a jet pointed directly at the telescope. So this is what I was researching, what I was looking at for my PhD, and then following up on that, I spent 5 years in total doing research fellowships, first of all in Stockholm, so in the Royal Institute of Technology, KTH in Stockholm. And then in Munich, I moved to the Max Planck Institute for extraterrestrial physics. So that was obviously a really good thing to be able to say to people when they said, where do you work? I say, I work at the Institute for Extraterrestrial Physics, because it sounded like I was looking for aliens. Now I wasn't, but you know, it still sounded cool. So I moved back to Ireland then in the middle of 2013, and I was still involved in the space area, but I was getting closer and closer to the Earth. So I was working for a company called MBio, which were a spin-out company from UCD, and MBio was a materials engineering company. But it was working again with the European Space Agency, but it was actually working on coatings for heat shields. So this instrument here is called the Solar Orbiter, and basically it was launched in 2020, and it was designed to look at the sun. So it's designed to look at the basically components of the environment close to the sun, so the solar wind and the kind of plasmas being emitted from the sun. It's the closest mission to the sun. So there were two satellites kind of launched fairly close together in time, one from NASA and one from ESA, but they're both measuring slightly different elements of the sun's kind of characteristics. But the job for MBio, which was done in Clonmel in County Tipperary, was to actually, and in Dublin as well, was to actually coat the heat shield that was going to be the closest part of the instrument, or of the satellite, to the sun, and to protect all the instruments. So you can see in the picture here, this glowing bit at the front is basically the heat shield, which is a whole set of layers of foils which are coated in black to reduce the temperature. So that each layer of foil kind of reduces the temperature a little bit more and a little bit more, and a little bit more, until you get to the back of it, and actually it's protecting all of the instruments. So I worked in MBio for a couple of years, and then after that, oh, sorry, just trying to change. After that, I moved to a different spin-out company called Parameter Space. So this is also based in UCD. So I spent a lot of my recent time in and around the area of South Dublin. I'm still in South Dublin now, I'm in Deeds Grange. But basically, Parameter Space was a spin-out company which was looking at data analytics for different scientific missions. So they have been looking at data analytics for another scientific mission to look at the Milky Way. But part of the project that I was involved in there was also to look at a platform for Earth observation data. This was the kind of the first point, I suppose, at which I came to actually looking at the Earth, as opposed to looking out beyond the Earth. So I was kind of managing the project to develop a sort of a prototype data platform to be able to show Earth observation data and link other types of data to that around Ireland. And then in 2018, I moved to TechWorks Marine. So I've been here for just over 5.5 years. I took a bit of maternity leave the end of 2022, beginning of 2023. So I'm back kind of in the company now a little over 8 months. But since then, I basically started in the company in 2018 as the Earth observation lead. And since 2020, I've been the Chief Operations Officer. So the company is basically a marine data company. So what we do is we collect data for offshore energy companies, such as renewable wind or tidal, information for ports and harbours, for environmental agencies, and also then for marine research as well. You can see in the top corner here some of the examples of some of the buoys that we've deployed. So we deploy very large data buoys in the water to collect information for any time between a couple of months to a couple of years, to allow the engineering company or the port to make an informed decision about how they're affecting the environment, or to prove that they're compliant with protecting the environment, so they're not causing any issues to the local marine environment, to the marine wildlife. So what the company does is a little bit of everything in terms of an end-to-end system. So there's data buoys, there's also data management and delivery, and then there's also value-added products and services. And that's what I'm going to talk about a little bit more over the next kind of 10, 15 minutes. So basically, what we do is use satellite data to either complement or build on the in situ data that's collected, or completely separately, we build data products. So I'm going to jump straight in then to talk about I'm going to skip this a little bit because this is just a little bit about what the company does in general, but I'm going to focus a little bit on the EO element in particular. So there are a number of different areas, I suppose, that we've spent the last few years looking at in terms of combining satellite data and in situ data. So a few of the examples we've looked at are around waste crime. So waste crime both at sea, but also on land. I'll talk a little bit about it in a few minutes. We've looked at how you can use satellite data for monitoring public health. So, for example, is there a way to infer the presence of E. coli in waters, particularly after periods of heavy rainfall or periods where there's a lot of nutrients being released into the water? What can be done in terms of renewable energy, and then also what can be done in terms of looking at marine protected areas, looking at the kind of biodiversity in the area, so looking at seagrass or looking at the intertidal zone. We've got a small team here who've been working on a lot of these. So really, I am a woman in the geospatial area, but I'm not really doing the geospatial analysis necessarily. I'm basically managing the teams that are doing it. So I'm going to give all of the credit for all this work to my team here, who are really great at just digging around and getting really, really kind of interesting results from the data. So one of the things we were looking at over the past couple of years was how you can infer the presence of E. coli. So the main reason for this was that especially during COVID, it became more and more obvious that there was an ongoing release of wastewater into Irish coastal waters, particularly when people were staying at home and doing a lot of sea swimming and kind of going, oh, wait, hang on, I can't swim today because of E. coli. Can't swim today because the beach is closed. This is kind of a pain. But the biggest issue was that, and it's still the case, that there's only manual monitoring during the season. So the season is only from May to September, and you have to then send the water off to a lab to get processed, and the users are not actually provided with the information on a timely basis. So this became quite a big issue, especially when people were kind of sea swimming all year round and kind of saying, well, actually, hang on, this doesn't really help. So what we were looking at was, is there a way to identify E. coli events through kind of statistical analysis, machine learning, and combining local measurements of E. coli with satellite observations to see what would happen. So there's an example here using both optical and SAR observations. So you could actually see, that there's a wastewater plume coming out from Ringsend. And I think this was all over the news for a little while, a couple of years ago, but it was a real issue. And there wasn't anything reported to the EPA, although you could actually see the plume coming out for several hours. There was a lot of media kind of uproar about it at the time, but it kind of seems to have faded away. And it's not really evolved, unfortunately. So we took both Sentinel-1 and Sentinel-2 data. We took basically all of the data that was available through the EPA and through the local councils around the coast of Ireland in general, but here just giving an example, kind of around Sandycove and around the 40-foot. So combining all of the lab analysis, which it provided E. coli information and also information on local salinity levels and pH, and then various atmosphere and ocean model data plus satellite data from Sentinel-1 and Sentinel-2. And what we found out that you could do quite a good bit of information was available, maybe not quite enough in situ data really, but training of some of these machine learning models to give an indication that you could see blooms, you could predict blooms. We confirmed that salinity and rainfall were important proxies for water inflow, which we kind of, I think, already knew. But something like the SAR data could definitely be looked at in further details for water quality assessments and predictions. So you could get potentially a good relationship to backscatter and E. coli parameters. So that's one example of what you can do, I suppose, with Earth observation data. One of the other things I thought I would talk about just briefly is the Cameo platform, which is a national platform funded through the Disruptive Technologies Innovation Fund, the DTIF. It is being led by UCD, but has a number of SME partners within it, so ourselves, TechWorks Marine, Compass Informatics, and Treemetrics, who are a forestry-based company in Cork. But what we were looking at is to provide kind of detailed turbidity and chlorophyll product information and looking at the intertidal zones. So what you can do is you can use the local tide gauge data, which is available from the OPW, and look at the intertidal blue carbon, so particularly around growth for seagrass and that kind of thing. What we have done is we have it up and running ourselves on our data portal on a fairly regular basis. So if you're interested in talking about it a bit more, I can put you in touch with some of my colleagues. But this is an example of, I suppose, a kind of a demonstrator that's going onto the platform itself. Another example, I know Indiana is going to talk about flood prediction and flood forecasting, but we've had a little bit of a look at this. Been working with the OPW for the past year, 18 months, because they have a lot of flood events listed on the database, but they don't really actually have any measurements of the extent of each flood. So this is looking at the historical data. We're not talking about predicting floods or anything like that. It's just literally looking at the data points that have been collected in the database and looking at the satellite data that was recorded at that time to see, can you map the actual full extent of the flood area? Give them a bit more information that they can then feed in, which would help in the OPW's predictions. So especially if you're able to link that into the local river gauge network, so you can then look and see, are you at for the satellite data event, are you looking at the high tide mark, are you looking at the low tide mark, are you looking at the peak of the flood, are you looking at previous to the peak of the flood? are you able to then also map areas that were flooded but not actually recorded in their database. And I've got an example here from my colleague Peter, where he was looking at the flood extent in Sligo Bay. So coming up to nearly this time last year, actually. So you can see there are various areas where there was a report marked in orange, but you can actually then measure the extent of the flood from the SAR data. And what you can do then is actually ground truth the flooding extent from reports, from news articles, which is also what the OPW does. So they go out sometimes and they'll either send somebody out to photograph the area, or they'll look on social media for events reported, just to collect as much information together as they can. And actually, I'm going to go back for a second here, because I was talking a little bit about the intertidal zone elements. So this is just an example back here from 2023 in the intertidal zone in Skerry, so in kind of North County Dublin. So you can look and see where the actual submerged area is, and you can measure the NDVIs of the actual sand, marshes, the seagrass zones that are growing there. And one of the things that we're quite interested in is how do you actually then quantify the amount of carbon being stored in seagrass areas. It all links into basically retaining the biodiversity of the area, monitoring for climate change, and then also looking at carbon offsetting. Through these. So yeah, just to give you kind of a snapshot and to give you an idea of some of the very, very large sets of equipment we have, we basically use a lot of our in situ data to complement and to validate the satellite data that we have. So we've done a few projects over the past few years about validating satellite data in such in areas like in and around Dublin, where it's very cloudy, but you can still get a kind of decent set of data over a long enough period of time. You can actually then validate the kind of satellite data sets that are coming down against the in situ data. And that's this large buoy here is an example of one of the buoys that we've used for that kind of work. Then we've got much smaller ones, so you can see these guys are beside a boat. They're basically a couple of meters high, but they're really good for putting out on kind of coastal zones, so not very far offshore, and you can use them for all sorts of monitoring. And we're also in partnership with a company that provides LiDAR data. I've probably finished a little bit early, but maybe that's a good thing. But my details are here, and I'm happy to talk to anybody who's interested. And thanks very much for your time.
That's great. Thank you so much, Sinead. That was really interesting. There is a Q&A facility, so you can use the chat or the Q&A facility if you have questions. I don't think people are allowed to unmute themselves, so do come in on the chat. Yeah, that's fascinating. Have you discovered anything about the sort of seagrass beds in particular around the coast of Dublin?
Not really. It's kind of a work in progress at the moment. So, oh, sorry, I think I'm talking over you there. Sorry.
I was just wondering if you have any ground truth data to work with for seagrass.
We haven't really looked at the ground truth data at the moment, no. But it is something that, yeah, we're going to need to collect a bit of ground truth data, I think, to build on it. We've kind of just started looking at it recently, but it's kind of quite an interesting concept. So, yeah, we haven't got any yet, but yeah, we definitely plan to go out and collect some.
Yeah, great. Yeah, it's a really interesting concept when it comes to sort of carbon sequestration. and also biodiversity restoration in the oceans. You know, it's actually one of the key habitats. So it's amazing that, you know, not very much seems to have been done in Ireland about that so far. But I'm sure,
yeah, exactly.
hopefully,
I
with the
mean,
nature restoration law coming into effect now, that's going to change, hopefully.
yeah, I mean, I think, yeah, as you say, like it's really important in a couple of different ways. So I think it's really interesting. It's, you know, yeah, it's, we want to know a little bit more about it in the first place, and to, you know, how you can actually, how much carbon is being sequestered there, or, you know, how do you actually quantify that? You know, is that something that Ireland can use in the future then for its kind of carbon offsetting goals and that kind of thing? But then also, yeah, how do you then, once you've identified how much is there and how much it's sequestering, how can you then actually protect it to make sure that in the long run you can then keep using it as sort of a carbon sink?
Yeah, absolutely. Or restore the fields to what they used to be.
Exactly.
There are two questions. Zita Karki is asking, what was the result of the radar for water quality?
So for looking at the E. coli, you could definitely see that the SAR data was linking. I don't remember exactly because I wasn't the one doing the work. I will freely admit that. But you could get quite a good correlation, I think, between the SAR backscattering and I think in particular the kind of the rainfall measurements and salinity. There was a good link between them. So it did look like you could use SAR definitely for kind of predicting, I suppose. Well, from what I remember, we sort of expected that for the SAR data, you would have probably smoother areas of sea surface where you would have something coming out that, for example, might have nutrients and might have oil or something like that. But I think it's a tricky balance, because if the sea is too rough, you're not going to get kind of decent quality measurements. So you are probably kind of limited a little bit in terms of the weather conditions as well. But what we got, I think, looked pretty promising in terms of being able to use the SAR data.
Yeah, great. And Bruce McCormick is asking, could you speak briefly about financial costs to clients without giving away confidential information?
Financial costs in terms of the big equipment, I'm guessing, I don't know. I mean, it's so
well, maybe in terms of EO and how you can make savings compared to putting out the big equipment.
Sure, yeah, exactly. Well, so the Sentinel Sentinel satellites, which are all provided through the Copernicus program, they're all free open access data. The reason behind that is that the European Space Agency decided if you provide the free and open access to the data, you're getting large volumes of data, and then companies can basically add value onto that. You're going to still get a significant cost saving using Earth observation data versus using large and probably medium-sized buoys. A lot of the costs around deploying equipment really comes down to vessels. So you need to have vessels that are capable of being able to deploy the equipment in the water safely. And that essentially costs quite a lot of money. The actual equipment itself, you know, is kind of leased out, and the data is it's really all about the data. So what we do is on a kind of project by project basis, we supply the data to the clients. So we own the equipment, we own all the sensors, we rent them out basically on a daily basis to clients, and we then provide the data to them as a service. So if you're looking at Earth observation data, there's going to be quite a large cost reduction. You can build in probably some validation around that if you want to make sure that you can really trust the data. But in the long run, the EO data is going to be more efficient cost-wise for sure.
Great, thanks very much, Sinead. Sorry we don't have more time, but maybe we'll have you back again at a later date to talk about some.
No problem.